Okay, whoa, where did the stuff go? What do we want to emphasize here? Radicals. We're looking at radicals now. And again, you're just working your way through this really. 27 is the cube of 3, so we'd say it's the cube root and that. And, important things here, some vocabulary. The index, that's what's in here. That tells you what root it is. The radical sign, this shape. And the thing under the radical sign is called the radicand. And if you don't see an index, then it's assumed to be a 2, right? Because that's the most common, which would be a square root. All right, let's scroll through. You're going to copy and complete this table. Again, the answers are posted online. You may want to print them all off or check them as you go through them. And we're listing the first 15 perfect square numbers. It's a good idea to have an idea what the squares are. And really, I think here what we're doing is, oops, I'm highlighting. I think what we're doing here is really just listing the first 5 perfect square powers. In other words, powers that have a square root, right? X squared, x to the 4th. And, then what about it? And then the same thing, same idea with cube roots, both the cubes of numbers, because you need to know what numbers have, or, what the cube numbers are, the numbers that have a cube root, so the first 10 perfect cubes, and the first 5 perfect cube numbers, powers, right? 5 powers. So powers that have cube roots, right? We're interested in both numbers that have cube roots, like this, 64, and like this, x to the 9th, right? And x to the power of 9 has a cube root, okay? And how do we get it? That's what we're interested in. Okay, how do we get that? And then again, we've got higher roots, so 4th powers. So I think, again, this time we're really interested in 5 perfect 4th powers and 5 numbers that have 4th roots, as well as 5th roots, and then a little bit of summary. And now we get into simplifying radicals. Okay, so we've done radicals. Now let's simplify radicals. This is all part of the radicals worksheet, so it just carries on. I might actually help you out a little bit here. So a radical is in its simplest form if the following are true. The radicand does not contain a fraction, where am I? Here we are. Does not contain a fraction or any factor which may be removed. The denominator does not contain a radical. So radical is not in its simplest form, right? There's a perfect square that comes out of root 24. There's square that comes out of what power of x to the 7th can be factored out. Okay, and we're not allowed to have a fraction, we're not allowed to have a radical in the denominator here or here or here. So what are we going to do with these things? So let's just take a look at root 24. Okay, what's the procedure here? What I want to do is I want to write 24 as a product. Okay, now I could go 24 times 1, but that's not really going to help. 12 times 2? Nope. How about 4 times 6? So it's the root of 4 times 6, which then becomes root 4, root 6, and root 4. So why did I choose 4 times 6? Because 4 is a perfect square. It has a square root. So this is 2 root 6. Okay, let's take a look at something here. What if we have a more complicated expression, root 20? Can I write 20 as a power? And so I can. 4 times 5. Okay. 4 has a square root. 5 doesn't. B to the 9th. Can I write that so we have a square root? Yeah, I can write it as B to the 8th times B times c to the fourth times c. Okay, and then we can pull these out. Now this expression is equal to what's above. So it's equal to root 4, root 5, root b to the 8th, root b, root c, whoops, nothing up there, sorry, root c to the 4th, and root c. So you really don't need to write this line here. Okay, you can go straight down to it's root 4 times root 5, which becomes, okay, what has roots? Well, 4 has a root, it's 2. B to the 8th has a root, b to the 4th. C to the 4th has a root, is c squared. And then what's left? And this we put together, right? Everything that doesn't have a square root, so the 5 and the b and the c. So 5, b, c. So that's how that expression is simplified, right? And basically what we're doing is we're saying we don't need to write this. We'll just write it as a product of roots, and we don't need to write this, but we do need to keep in mind, okay? So we want to take, again, we want to take the number and write it as in factored form as a product where one of the products is a perfect square. It has a square root, okay, the largest one. Or in the case of the next line down, let me just move down here, where we have cube roots. So the cube root of, let's say, negative 500 is the cube root of negative 125, seeing as this has a cube root, right? And 500 is 125 times 4. So root 4, and remember the 3, the index, right? These are cube roots. So it's negative 5, that's the cube root, okay? And this is equal to, so let's put some equal signs, equals negative 5 times the cube root of 4. Okay, so that's simplifying a mixed radical, right? Okay, so just what you did before, writing it as the product of things that have roots. What root? The root that you're looking for. Square roots up here and cube roots down here. Okay, and we'll go on. We'll do some fourth powers and fifth powers. So let's take, how about this one here? So what has a fifth root, right? So x to the 5th has a fifth root. X to the 10th, x to the 10th has a fifth root. And then that will be multiplied by the fifth root of x to the 4th, right? X to the 10th times x to the 4th, you add exponents. The fifth root of x to the 10th, you divide by 5, gives you x squared times the fifth root of x to the 4th. Okay, so this again is all work that you're going to work through. And let's see, express as an entire radical. Okay, 5 root 2. I can never find my pen here. So let's say we had 3 root 5. Then what I would do is I would write the 3 as a root, and 3 is the root of 9. So I would have root 9 root 5, which is root, and you just put these two together, right? 9 times 5 is 45. So we have the mixed radical. We take the 3, put it back under the root sign. Since this is a square root, we'll just square the 3 and multiply. 9 times 5 is 45. Okay, and now, of course, you can work on these. And, oh, here, I'll be nice. I'll do one for you. Let's do this one. So I want to write the 3 as the cube root of something. So 3, or actually really the 3x. So that'll be the cube root of 27. 3 cubed, the cube root of 27 is 3. And the cube root of what? The cube root of x cubed is x. And that's multiplied by cube root 5. Okay, and that's equals. And And so we now just combine. So it's a cube root. Don't forget the index, right? It's a cube root of 135. That's 5 times 27. And x cubed. And that's expressed as an entire radical, right? Put it all together. To express these in ascending order, that is from smallest to largest, then what you need to do is take each of these mixed radicals, express them as entire radicals. Okay, so for example, the 7, okay, so to put it under a cube root sign, I'm going to have to cube it. So it's the cube root of 343 times the cube root of 3, which is the cube root of, well, what do we get? 3 times 3 is 9, 3 times 4 is 2, carry the 1, so 1029. That's the cube root of 1029. Put these guys together as, entire radicals, and then you can compare. Right? If you have cube root of 1028, that's smaller. Cube root of 1030, that's larger. And, lots to do for you, but we've got a couple of days. I'm just going to move this over here. Okay, so you got a couple of days. You can ask for help in class. This will take us through, one period, and then the radicals. Well, one period is classifying numbers and some textbook stuff, and then this worksheet on radicals, which is to be continued the next period into simplifying radicals. And we'll stop here, and then we'll pick up one more with simplifying radicals with variables.